Okay, I want to start this off with a review of radicals and how to simplify them. I don't know what you might have called it in the past, but I call it a factor tree. So I'm trying to divide 32 by the smallest prime number. There we go, 2 and 16. 16 is divisible by 2, and then 8, 2, and then 4, and 2, and then 2. And because this is the square root, I'm going to take a pair that comes out of the square root, another pair. So the second one comes out of square root, and the one that's left over would be the 2. So I get 4 square roots of 2. Now, if I change the index to, say, cubed root, now I'm dealing with groups of 3. So there's a group of 3 2s, so 2 comes out. And there's a pair that's not. So underneath the cubed root would be another 2 times 2. So 2 cubed roots of 4. Okay, now if we're talking fourth root, let's see, let's grab another color here. Same factor tree, but because of that 4, I'm looking for 4 numbers. So there's 4 2s. So 2 fourth root of 2. No, there you go. And kind of the idea of all this is that these are radicals, because this is a radical symbol. This is called the radicand, the 32. But that radical could be the square root, it could be the third root, it could be the fourth root. And what we're going to do is relate those to rational exponents. Or when you think rational, hopefully by now you've noticed that that means fraction exponents. So for example, if I were to take the square root of 2, that is the same thing as 2 to, well, there is a 2 that's assumed right there, so it becomes the 1/2 power. Okay, so the square root of 4, you know the answer, it's 2. So that becomes 4 to the 1/2, which is also going to work out to be 2. Okay, 1/25 to the 1/3, because it's the cubed root. And this works out to be 5, so does this. Okay, fourth root of 81, so 81 to the 1/4 power. And then 32 to the 1/5 power. So whatever that index is on the outside becomes the denominator of my fraction to give me a rational exponents. So just a bunch of practice here. I might go through all of them, I might not. But this is the square root of 7, so 7 to the 1/2 power. If I go too fast, just kind of slow things up. But the inside here I'm going to write as 2 to the 1/3. And outside of that I'm going to square it. So these two exponents here get multiplied. So 2 to the 2/3 power. Okay, 12 to the 1/4 power. 5 to the 1/3 power. Okay, 15 to the 5th, but I'm going to raise that to the 1/6. So again, I'm going to take those two, and there's a 6, sorry. I'm going to multiply those together to get 15 to the 5/6 power. And then lastly, 10 to the 1/8 power. So I'm just writing those in rational exponents. In other words, fraction exponents. Okay, not changing the value, just trying to change the way it works. So now I'm going to take these and go back to a radical. So that means that you've got like a symbol like that. Square root, cube root, fourth root, whatever. And that is going to tell me what root. So this turns into the square root of 3. Okay, so the bottom number here is going to be my root. So I'm going to have the cube root of 5. And make sure you put a little 3 there to make cube root. But that 2 just means that that is going to be my power. So squared. Or I could write it as 5 squared underneath the radical and make it the cubed root on the outside. Either one works. Kind of depends on which way you want to manipulate the expression. Okay, the fourth root of 6. Okay, the cubed root of 4. Okay, the 8th root of 16. Okay, the 12th root of 25 to the 7th power, or 25 to the 7th power underneath the 12th root. Either one works. Okay, so how can I evaluate these and without a calculator? So 625, I'm going to do a factor tree. It ends in a 5, so it's divisible by 5. 5 and 125, 5 and 25, 5 and 5. There's 1, 2, 3, 4 5s, and we're doing the fourth root, so this works out to be 5. Okay, now the fourth root of negative 25, that's not possible. Okay, because I can't take a negative 5 times a negative 5 times a negative 5 times a negative 5 and get a negative 625. If I have 4 numbers that I multiply together, if they're positive or negative, because it's even, I'm going to end up with a positive answer. And that's why I can't take the fourth root of 625. Okay, here we go, 81. So we'll go 3, 27, 3, and 9, 3, and 3. So there we go. I got 4 of those 3s. So my answer works out to be 3. Okay, so this one here and this one here, be careful, including these ones right here with the negative numbers. Parentheses matter. So now, since there's no parentheses around that 81, the negative 81, the negative is not included. So it's going to be this, the fourth root of 81, which we know the answer to, and make it negative at the very end. So this works out to be a negative 3. Okay, here I'm going to take the cubed root of negative 27, and then I'm going to square my answer. Now, negatives and odd indexes, so third root, fifth root, seventh root, those are fine, because I can take a negative 3, negative 3 times negative 3 times negative 3 to get me a negative 27. So that's going to become negative 3 to the second power. And parentheses are very important. This means that I'm going to take both the negative and the 3 in a square and get a positive 9. Whereas the one next to it without the parentheses, that means I'm just going to take the cubed root of 27, and then I'll square it, and then I'll make that answer negative. So essentially the same work, but you get 3, then you square it, 9, and then you make it a negative 9. So be very careful. Okay, negative exponents. I know it's really difficult to see that, but negative exponent means to take the reciprocal of the base. So what I'm going to do here is I'm going to take this 9 and I'm going to make it 1/9. Okay, better yet, I'm going to take it to a different level. I'm going to ignore the negative right away. So it's the square root of 9, which is 3, then to the negative third power. Okay, so that negative means it's going to become 1 over 3 to the third, so 1 over 27. Okay, here I'll go tackle the fifth root of 32. Notice how the negative didn't get put underneath that fifth root symbol because it's not in parentheses. I'll put that negative out there and do it later. And then eventually I'll take it to a negative third. Okay, fifth root of 32, we do the factor tree. I'm going to save you the time. It ends up being 2 to the negative third. Okay, so that negative means it's 1 over 2 to the negative third. And don't forget about this negative, sorry, positive third. So negative 1 over 8. Okay, without a calculator. So why are all these roots and indexes and powers important? Well, I can solve using different type of roots. So if it was a quadratic, I use the square root. But since it's a cubic, I'm going to use the cube root to both sides. So x is equal to 5. Here I'll do a little bit of work. I'll take the divide by 3. I got x to the fifth that's equal to negative 1. And because it's the fifth power, I'll take the fifth root. So the fifth root of negative 1, negative 1. Okay, I'm going to try to get it so it's like this. So I'm going to add 3, and that's going to give me negative 16. And divide by 2, and that's going to work out to be negative 8. Take the cube root because it's the third power. And that is going to give me x plus 4 equals negative 2. So x is equal to negative 6. Now, I don't need a plus or minus when I'm taking the cube root or the fifth root or whatnot. It's when I come over to here and I add 7 to make that 10,000. And now that I take the fourth root, now to save you time on the factor tree, 10 to the 10,000 is 10 to the fourth power. So if I take the fourth root of 10 to the fourth power, I get 10. But this time I have a plus or minus because of the even root. Because if I put in negative 10 to the fourth power, I'll get 10,000. Just like if I were to put in 10 to the fourth power, I'd also get 10,000. And both of those minus 7 gives you 9,993. Okay, there you go. So that's converting radicals back into rational exponents. Later on, we'll use those to kind of do some operations with them.